Good evening, everyone. It's a tremendous pleasure to welcome such a full lecture hall. It says that we are really in emergency to change our architectural profession. So yeah, dear colleagues, dear students mostly, and esteemed guests, I would like to warmly greet all of you on behalf of TU Wien to today's symposium titled Material Reuse Strategies. The title defines that we really need to today critically assess and challenge the role of our architectural practice, as we need to acknowledge that it's part of a complex construction vortex that contributed to the fact where we are today in terms of our environmental urgency. It also seems that we require an intense unlearning of our ordinary belief that we have the infinitive of extractive construction materials and that we can always count on that. And that we need to take our responsibility in trying different strategies for materials and for our practice in the future if we want to a little bit contribute to the changed conditions of the future of our planet. For those who don't know me, I'm Tina Grigoric, practicing architect and current professor here, and the chair of the Institute of Architectural Design. It's an honor to welcome here today in Vienna two speakers whose work of their practices, it's the key why we are addressing this very, very important topic today, and which they are representing two leading European architectural practices that have been dealing with this specificity. So BC Architects and Rotor. So Nicolas Coeckelberghs of BC Architects, and Victor Meesters of Rotor. They're going to challenge each other, presenting their strategies, how their practices have been working for more than a decade, or almost 2 decades in some cases. I have been following their work for their very beginnings, from 2005, Rotor, or 3 maybe. I think it was inspiring to see that there is also the time that we started our office, another way of practicing architects and actually going more to the core, to the construction side, to deal with the things that usually it's not evident. So we wanted to organize this particular symposium as part of a design studio, which you see a little bit of the research and the current conditions of titled Culture in Residency, Adaptive Reuse, dealing with a building close to in Sekirn on Wörthersee, a modernist building, and how to adapt it to the future use together with students, and together, of course, with Jakob Traunig and Gordon Seelbach. This design studio actually belongs to a larger contingent of design studios that addressing the topic of reuse at the TU Wien, which has been very present focus for the last semesters. We try to, with this intentionally, we try to prioritize intelligence reuse strategies of existing buildings, and we try to explore new approaches also on the level of the materials. To outline, with this small talk and mostly a discussion after your pitch presentations, we are aiming to further open a discussion the necessity of exploring the material reuse strategies as the new fundamental ways of our practice, which is very hard, very complex, and it changes the way we think and we work on a daily basis. And central to discussion will be the focus on organizational and also operational aspects. So very practical, how our practice day to day, week to week could change, how our processes that we have been, that became common in doing an architectural project will change, will hopefully change in the future. and also how the role of architectural institutions as TU Wien would follow that. So we are also trying to see a peek into understanding how this kind of reuse strategies, collecting of the defunct material, demolition material, opening up or exploring or promoting new materials which come from basically either urban mining or the demolished material, and how these new possible material cultures could shape the future of the construction sector, which we are a part of. The symposium was kindly also supported by LINA, Learning, Interacting and Networking Architecture, a European architectural platform. We are happy to somehow intensify this discussion, the urgency of the material discussions and how we are going to use it as part of our practice. And now I'll ask Jakob and Gordon to introduce the speakers themselves.
Thank you, Tina. I'll do a short introduction to BC Architects and Studies in Materials, and of course Nicolas himself. So I got to know your work actually only a couple of years ago through the involvement of working on the project at Atelier Luma in the south of France, where basically their work was mostly focusing on how to approach or how to work within a bioregional approach to sourcing local waste materials, particularly minerals, and how to incorporate that as part of the construction process. Which in itself is a nice story, but I think also what's even more interesting is that you operate as a larger collective, which has a three-part organization structure, which you will explain a bit more, but the kind of self-initiative structure which goes beyond the traditional architectural just practice, but also having its own non-for-profit laboratory where you test different things, where you educate, but also to have your own cooperative that deals with what is nowadays perhaps seen as a somewhat fashionable, also maybe niche practice of working with materials. We see it everywhere, but I think this is where you are all interesting, because I think you mentioned that once during a conversation that you go beyond the niche practice by doing a type of co-working with the industry itself. So this is where the actual systemic change starts to happen. So I think you will probably elaborate on that even more. So thanks for being here today. Maybe also some words to your background. So you started. You studied. You have your master's degree from the architecture of St. Lucas in Brussels, and you also did a postmaster in urban architecture, specifically at Crater in Grenoble, and you're currently also teaching at U Hasselt, amongst also other visiting professorships around the world, testing the idea of application of urban materials in different contexts and what differences does that bring, and sensibilities that we need in order to do that. So please welcome Nicolas.
Perfect. Hello, thank you, Jacob, for the nice invitation. I'm super pleased to be here. Oh, sorry, spoiler. Should I do that or? Yeah. So, no. How do I have to do it? Just to. No. Well, it's okay, but yeah, I know, but it's okay. So, hello everyone. I'm Nicolas from BC, and like Jacob explained, I'm one of the four co-founders of BC Architects, Studies and Materials. And yeah, nowadays it's a practice. Actually, it's 3 practices, 3 company, 3 legal different entities that we needed to create in order to practice architecture like we wanted to do it. So for the moment we have 15 persons working at BC Architects, or 15, 20 persons working at BC Architect and Studies. BC Architects being an architecture office specialized in bio-sourced, geo-sourced and urban-sourced materials. So circular building. BC Studies being a non-profit organization where we do projects abroad, non-profit projects, but also organize workshops in order to experiment, learn, and teach about sustainable solutions. And BC Materials being a cooperative that is not selling services, but selling building materials made of earth, mostly coming from excavations from the cities. I will start a bit with explaining how I think our vision and how we envision architecture. I think it's quite clear that we see that there is nothing really new in what we are doing, what we have to do, and it's actually a bit looking back to how we were building before. And it's yeah, like the slide is saying, it's always been a common sense to work with scarcity, with material, with a lack of materials, because it was complicated to transport, and so working with around you was normal, and so we're going back to that. And I like to illustrate this also with this. This is the vernacular architecture from the Flanders, this specific region in Belgium, and this specific barn, for example, is from a farmer. That build it is what it's called waddle and daub technique. It's a wooden frame in oak filled with earth mixed with straw, and the farmer would build it next to his land where there is cultivation. And this specific farm was disassembled a second time when the farm was not usable anymore, or there was no possibility to grow more. And so it disassembled it 2 times, and then even a 3rd time it been disassembled again to go to an open-air museum called Bokkerijk in the Flanders for the World Expo of '58. And so you can see that 3 times in a row this wooden oak structure that was super strong was disassembled. The earth infill was just thrown away in the neighborhood. It was actually compostable. There is no waste with what's in it, but these valuable elements that are the oak beams was reused. And so you see it, for example, here really well, because we disassembled, that was a project of BC Architects, Studies and Materials also to refurbish this barn in the open-air museum, to transform it for this 4th life into a bakery. For the open-air museum. And you see that all the beams are actually numbered. They are attached by this kind of pen connection. So yeah, that was for us quite interesting to see that there is nothing new, you know, this open frame structure, and then refilling it. And there we didn't fill it with earth anymore, but we filled it with hempcrete, because we had this need to make a volume that was insulated, where you could actually keep the heat better. And so I like this example, because it shows that it's again not really new. So with BC, what we try to do is then first to think about the project. Is this really necessary to build? To say no to a project, it's sometimes the most sustainable thing that you can do, because then you don't build, you don't need any materials. Then of course you have to look about sharing, reusing, and of course renovating. And if you want to build, then you build through first geo-sourced, bio-sourced, or what we call urban sourced, as reuse of materials. And I would say this is a bit the principles that we try to apply on every project proposals that we receive in order to start with it. And how did we start? Well, it was more than 10 years ago, yeah, I think 15 now, or yeah, something like that, with my 3 best friends that are the 3 other co-founders from BC. We were studying and we received this great opportunity to go to Burundi just after graduating, with the idea of, yes, we will manage to build something finally, a library. So it was quite of a certain scale project. So, and we thought that we would be going there in order to teach something or to create a certain impact. And then we went to this place where we actually discovered, we were super naive, and then we discovered that actually, yeah, there was no catalog of materials. You couldn't not find any materials in a shop. There was a shop, but all the materials that was imported were super expensive. Cement, steel was coming from Tanzania, so it was imported, super expensive. And so we saw that actually the best and economical way to build there, because we didn't have so much money, we had actually, we raised 20,000 euros to do this project. And so we had to do it with the budget, and then we saw that actually by looking around, there was many local solutions that we could apply. And that's, I think, through this project that we learned the most, and where we actually started to have some principle of looking around and not going too far to find solutions. So for example, here you see that you have this red laterite earth that is being used to make compressed earth blocks, the use of the eucalyptus trees in the back in order to make the beams, natural stones also, some clay plaster, fired tiles from the clay that is in the valley. So really like resources coming from, I would say, 5 to 10 kilometers maximum, because it was, yeah, the most logic way to build. Using industrialized materials would say increasing the cost, and spending as much money in labor was actually the best thing. Labor cost was absolutely not an issue there. I think a laborer was paid less than €1 a day, so it's really one of the horrible places in the world where actually there is no, the labor cost is very low. But it was magical to see that there was so many local solutions in order to build. And this is how we discovered that, yeah, you could actually dig a hole and take some earth and transform it into building materials. Of course, we were not so sure about what we were doing, because for us it was also quite new. We saw that people were doing it, so we knew that it was possible. But then we were looking into literature in order to understand, is there no some studies about it? And this is how we discovered the work of Crater in France, where I studied after it in a postmaster. And we discovered there is not only like millennia of knowledge about earth and construction, but that there is also a lot of modern science and construction books about how to reformulate and how to make earth mixture better and more durable. The crazy thing I think about this project is also that it was been done in a complete different way than a project that we would do in Belgium. It was done in a lot of trust, because we had no building permit, no general contractor, no tendering, no contract. Everything was done by trust. We had a client, but we were also having the money so we were also a bit part of being the client. So I think everyone was not very clear what was his role, but everyone had the same goal, is to make sure that this building was done well. And one of the most key elements, I think also, everyone had time. And that's sometimes also very important. But so here, for example, on this picture, you see, the contractor, Salvaged, is not a contractor, he's a foreman. He was looking for the skilled people around his village in order to come. If we had needed some masons, he was going for masons. But he was also helping us on the plans in order to see how we could improve certain stuff. And then after this project, we discovered that we didn't teach anything. We were like super young architect, but we learned so much by this experience. And in a very naive way, we took it back, and then we went back to Belgium with it. And then we started to try to apply those principles also on our project in Belgium. This is not so simple, I have to say, because then you arrived in an economical context that's completely different. Material cost nothing compared to the labor cost. So if you want to have a project where you use local materials, if you want to build with people, yeah, then you have to think differently, because it might be interesting, but it's very costly. So there, for example, for this project that is a bioclass, it's a classroom, I would say, inside an existing building. It's a fort, a shed of a fort, and then for this competition, what actually was like a normal competition tendering, we had to win the competition, and then we wanted to use the earth blocks and hempcrete also as materials, but it was super expensive, so we had to find ways to make this happen. I will explain later how. But again, we tried to use the same principle that we had in Burundi. We were looking around how we could find some resources. We could not use the excavations from the site because there was no excavations, there were no real foundation. We were reusing the existing foundation of the building. So we went a bit further. We went to visit different quarries in order to find resources in order to make bricks. And then we started to test them, to make some prototype, to convince everyone that it would work. Again, it was complicated to do all this prototyping or ask extra money to do that. So we organized some workshops in order to gain some time and extra money to make all those researches. We had to prototype because people were not really sure that it would work. On earth masonry or any earth techniques, you don't have norms in Belgium. We're using the German norms, the DIN norms. Sometimes we can use them, but most of the time they are not usable in Belgium. So we had to prove that it was working. And then in order to make blocks and to do this insulation in hempcrete, we had to organize workshops. It was a bit like a win-win situation, because in Burundi, we could hire 60 people in order to dig and then to make bricks. Here it was not possible. So here we create this win-win situation where people would come to help us by participating on the construction site, and on the same time we would learn together what are the principles about earth construction and learn about this new type of materials. And it was very, very interesting, because then you create also a community, also something that we also had in Burundi. And this community was there present, and then you start to feel that by creating this workshop, you also make a community, I would say, of people interested in making change, making impact into architecture. And so this is how we did our first mass production, but it's not really mass, but it's a production of 20,000 blocks in situ that we produced, not anymore with a hand press like we had in Burundi. By the way, if you go on YouTube, you can see some videos of how we made the bricks and the materials in Burundi, but also specifically for this project. So we involved a little bit there. We had these machines, electric machines, hydraulic press, in order to make better bricks, but to create them on site during these workshops. I will not show the video, but I invite you to have a look at it. It's nice to see. But then, by doing this, we call it this type of bespoke project, tailor-made project. So we did it for our own architecture project, and started to do that also for other architects that wanted to build with the local earth. So we started to do also some consultancies. We have, for example, there is a project in Ramdirt in like a watching tower in the Flanders in Belgium for the Gouden Lineal, and we helped a few architects also to build with Ramdirt, to reformulate the earth. So we gained this expertise in what we called reformulation, characterizing a certain type of local soil and then adding gravel or sand or this kind of resources that are missing in order to make a building materials. And at a certain moment we thought, yeah, it's nice to sell those consultancies, but it's going so far from architecture, and that's where actually BC Materials is born, that we had to divide and do a new company that was BC Materials. And also we discovered that doing all those studies, those consultancies to create a recipe of a material became also a bit expensive definitely for small scale project where you want to do a few walls or a few square meters of plasters. And then we thought, yeah, maybe it's cool if we can actually do one-time research around Brussels where we are working in order to understand what are the type of soils that we have in order to make ready-to-use earthen materials where you don't need to do any testing anymore, but that are ready for the market. And that's something also that we actually had as idea by being inspired by an exhibition in Paris at l'Arsenal. It was called Terre de Paris, where they also started to think about how much earth is being excavated by this big infrastructure work that will be in Paris. And then we were like amazed by the amount of earth that is being excavated every year in big cities like Paris, but also like Brussels or Belgium in general. You have 37 million tons of earth that has been excavated every year. In Brussels, I think it's 2 tons, and it's just like normal excavation for foundations, parking, and etc. And because there is so much of this soil, it's been seen as waste. And so most of the time what's happening with this waste is that it's been transported, sometimes quite far, to the Netherlands, but also to the south of our country, where you have a lot of quarries that have to be refilled, or actually where they gain more money by refilling the waste from the cities than continue to exploit the nice stones or etc. And so we thought, yeah, that becomes interesting, because we had this way of producing building materials close to the site and close to the place where we were excavating. But we thought, yeah, let's work with this waste, with these streams of earth that been excavated every day, where you have every day a truck driving around with 30 tons of Brussels sand, and use that as a main resources to make ready-to-use earthen materials. And then you can ask yourself, yeah, but this earth, what is it actually? Is it not like polluted, or is it not? Is it usable? Well, the good thing about Brussels, and so that's a research that we did of a few years, that we discovered that we have a lot of virgin soils that never saw the light. For example, here on the more higher in Brussels, in Uccle, they're digging there, for example, for making probably a few layers of parking lots. And then they come this Brussels sand. It's called Brussels sand. It's a virgin sand that never saw the light, and that is perfectly usable in order to use as a sand. Why is not used now as normal sands for making concrete is because there is a bit of clay in it, and it's too much work to wash them. That's this kind of things. It's been done in quarries, but they don't like to do that with the sand coming from the cities. Of course, to make bricks or to make materials, you need not only sand, you need a binder. In our case, we are not working with cement or with lime as a binder, or with no firing process to bind the material. We're using clay, raw clay, in order to bind our materials. So we need also that resource in order to make our materials. And here, for example, when you go a bit lower, 9-meter depth around the canal area, then you come to this Hyperion clay that we're also using as a binder. But there is also different type of clays that we are using to make our materials. And then for certain products like ram dirt or earth bricks, we need also to have more coarse materials, a material that will add some some granular skeleton to the resource that needs to make it more coarse. And then we're not using river gravel. We're using actually crushed concrete from demolition works, and that's also a resource that you have a lot, definitely in Brussels, where they are demolishing like too many buildings. So that's also a resource that we use, and this is how we started to sell a bit like a normal material reseller, like ready to use materials, being earth plaster, earth bricks, mortar for the earth bricks, and a rammed earth mix ready to use. And so those, of course, they are conditioned in typical bags ready for the contractor to use, to give them as less difficulties and make it as simple as possible, and to try to have another solution. And this is the product portfolio that we have for the moment. Different type of blocks, different type of colors of plasters, and also the byproduct that you need also to fix earth plaster, or to seal it, and to maintain it. And where we produce that, we do that in Brussels. So next to our architecture office, we have this workshop that we build it also in a circular way, because we are not so sure that we will stay there for long. So we had to build it with in a way that we could disassemble it and reuse exactly all the components to go to another place. And as you see, you have those loading bays there. The ground worker come and actually fill those 3 loading bays with those 3 resources that I was explaining. And then inside we are processing them, and processing means sieving, mixing, all activities that you can do on electricity, so there is no firing process. So if the transport is close, and that's what we try, we were operating in Brussels with the resources from Brussels, then you have a zero carbon material, almost zero, I would say. But of course, earth construction, that's something that it's quite forgotten. And so it's important that we see that it's as important to then create a certain offer for the market. We have to educate, and then we organize a lot of workshops for architects, but also for contractors to learn how to apply those materials. And we see that this is actually as important than create a material and create good materials. It's also to explain how to use those materials, because not like a concrete. It's not like concrete that it's been sold at a certain moment in history as the solution for everything, and you can do walls, floor, roof, everything. With earth, it's not like that. It's specifically for certain purposes in your building, and it's very interesting to use it also combined with other materials. So those are the things that's important to understand. And then I will explain also 2 projects that try to illustrate a little bit what we are doing. There is one project that we did with BC Architect and Studies and Materials together with Assemble and Atelier Luma for the Luma Foundation. I think many students went already to visit it and that are in the room now. And then another project, a research project that we are almost finishing right now, called YouTube, that it's a BC Materials project, but then more on a research base in order to see what we can do with the excavations for the Metro Line 3, a new Metro Line that's coming in Brussels. And this is a very interesting project, I think, on our for us, because it helped us to understand what could be the potential of earth in our growing market. So in Brussels, we will have a new metro line coming, and so there will be like not 2 million tons of earth that will be excavated next year, but probably 4 doubles as that. And so the clients asked us to look how we could think of revalorizing this kind of soils that will come from this excavation in order to make building materials. So the project is based on first, like the client being the metro owner, and then together also with the technical BBRI, the technical science, national science center from Belgium, and then together with different industrial partners and partners also doing some industry co-working. So first of the thing that we did there for this project was to look how they're going to be excavating the earth for this construction site. And we quickly saw that like making the tunnels, reusing the earth coming from the tunnels would be difficult, because in order to drill the tunnels they have to pump a certain additive that is actually clay. It's called bentonite, and this actually, I would say, pollutes, but it's not really like in the bad sense of polluting, but change the properties and the characteristic and the granularity of the earth and make it for us more complicated to reuse the earth coming from the tunnels. It's also then full of moisture and water, so we discovered that it was more easy to use the earth from the digging of the stations, because that's another way of digging and taking the earth from the soil. But still, it's a lot of potential of earth. And then we started to characterize a little bit the same test that we did in Burundi, but bit next level, together with also with the technical institute, we and the labs, we actually characterize all the different places where they would excavate in order to prepare ourselves of the moment that they would do the big excavations, to know, okay, here we have this type of soil. If we mix it with this, then we can have this mixture, and then it can do this type of bricks, for example. So we actually collected all the different samples from all the different metro stations that will be digged in the coming years. And then we saw all the techniques, and then we started to do also next to the research of the materials in itself, we had to think also, in what building material do we going to transform it? Because for the client it was interesting to think about reusing the soil and to put it in the new construction of the metro stations, but they said that the price needed to be low. So we also did and there's, I think, a very important part of the research. We also researched what are the different type of blocks, because we quickly went to this idea that if we would transform it to a material that has to be affordable on the square meter price, it should be masonry, because in Belgium this is very important, and the most common way to build is still masonry in small blocks. And so we started to investigate the price, the properties, bulk density, strength, compression strength, tension, etc., in order to understand what are the different type of blocks that we have on the market, and why is one block more expensive than the other one is more CO2 intensive than the other one, in order to place ourselves and to see what is the spectrum that we could go for making these blocks. And then we had to think also, okay, we will excavate all this type of earth, but if we produce them the same way that we normally do in Brussels with our small machine, the same that you saw, that's the project of Fort 5 in Edegem, where we produce the 30,000 blocks, it's too slow. We have this machine now, and where we can make, I would say, 8 tons a day with 2 people, but that makes actually the brick very, very expensive and through the labor cost. So we had to look how to improve the process, and this we actually did by looking to our neighbors, and we went visiting TerraBlock in Switzerland, Fetetera in Catalonia, and Cycleterre in Paris. Cycleterre being a company that has a mini factory to make compressed earth blocks with soils from Paris. Fetetera and TerraBlock doing also the same type of compressed earth blocks, but I think also super interesting, they are not building themselves the factory, they are doing this kind of what we call industrial co-working. So they are going to existing block factories in order to rent for a certain time their machineries and bring the soil, the right mix of soil, in order to make blocks. So that was for us quite interesting. So we went visiting all the different factories that they had, and also the different type of project and blocks that they were making. This picture, for example, that's 2 blocks and made in Belgium. On the right side is a fired one, and on the left side is an unfired one. So you see that, yeah, of course the color is different, the properties are also different. But what we quickly discovered is actually that many of the brick factories, fired brick factories in Belgium, they are producing actually earth blocks. So for them it's nothing new. So before going to the kiln and being burned, they're producing blocks, unfired clay blocks, on a very high production skills also. So then we saw, oh, there is actually a lot of potential. The only thing is to work on the mix and to see how to commercialize that. So we went visiting almost all the factories that you could imagine in Belgium in order to see, yeah, what are the possibilities and how open they are also to work with us, because that's another thing when you arrive as a young entrepreneur architect and say that, look, we would like to make low carbon blocks with excavation from the subway in Brussels. They look at you and they say, yeah, sure. So that's also part of the work, to be convincing and to see that there is something. So we went visiting a bit different factories. You know, in fired blocks, you have different techniques. Even in the firing blocks system, you have extrusion, where the earth is pushed in a formwork that is being extruded, and with a wire it's being cutted. But then you have also molded earth blocks, where it's actually the earth is pushed in a formwork and make this kind of adobe molded earth block. And yeah, that was amazing to see that, because yeah, the difference of production is crazy. Yeah? I was explaining the 8 tons a day with 2 people. We went visiting factories where they produce around 150 tons with 1.5 person for 1 hour work. So yeah, the scale is completely different, and then you can start to think about making the bricks more affordable and actually being able to touch more people. This also is interesting, because there it's a concrete block factory, so it's not a fire block factory, and they also have a very interesting machinery, because the system that we had of compressing, well, they have a vibro compressing machine, and so they're also perfectly able to be used and to think. And so now we started a collaboration with one of those, with 2 companies, one making molded earth blocks on the previous slide, and this one making compressed earth blocks. But of course, yeah, you're losing a little bit of this hyper locality, so losing also the fact of the being completely CO2 neutral, because we have to bring the earth there, and then we have to bring back the finished materials a bit further. So that was also a very important point in order to choose which factory we wanted to work with, was how well connected are they to different type of transport. So here, for example, they're close to the water, to the canal, and so that changed a lot also your result on the life cycle analysis, on the carbon footprint of your materials. And this was also, of course, a very important point to make decision to which factory we wanted to collaborate and which one was actually not an option to work with. And so now, yeah, next to all this commercial research and research on materials, we launched a brand to sell actually all those materials. So in a few days, it will be launched around September. we are happy to launch our brand. Invite you to go on www.leem.works and then leem.works, and then you will see. But on the BC Materials website, you will also be able to see this. But again, this is funny because, you know, I'm an architect, and if you would have asked me like 15 years ago if I would start to sell building materials, I would have said no. But so no, that's exactly what I'm doing. I'm going around to talk about those materials and trying to have a very interesting pitch about how sustainable they are and why they should be changing everything. So, but that's part of the deal. But so this. And I will finish now with this project. I hope I still have a few minutes. So this previous project, this YouTube project, this research project led to us to think about how to make Earth affordable, to sell it to more people or to bring it to more people. It's not about selling, it's about actually bringing it, because, you know, our BC Materials is a cooperative enterprise, and in our status of our enterprise, we wrote that our mission is to bring earth construction from a niche market to a growing market. So we felt that to create impact and to reach more people, we had to become a bit more, mainstream, I would say, or to also lower the price to make it more affordable, and not to be just. And not to be only for the lucky one. We were talking today during the juries that for example, ram dirt. It's a very, very interesting materials, but it's embracing a lot of craftsmanship, and so in countries where labor is expensive, it costs a lot of money actually, and so most of our clients that can afford ram dirt are super wealthy. It's always funny to see that then this earth you can use it to build in Burundi for people that earn €1 a day, but then on the other hand you have earth that's been sold for 1,500, 2,000 euro the square meters. But that's okay. But I think it's important to see that. And so this previous project for us, the main goal was to make it affordable, to bring it to everyone. So this commercial aspect is important. But on the other hand, we still like a lot to embrace craftsmanship, because I think it's important also, this materials has its potential to embrace skills and people knowledge of doing things. And this project in Luma, I think, is one of the best illustration of this embracement of craftsmanship and skills. So for this project in Luma is situated in south of France, in Arles, where the the latest building of Franco Gehry is being built, museum. It's the tower in the middle, and it's situated in the park where you have, it's a former train workshop. And there we have one Atelier Luma that has been a research center for the foundation that actually is learning about and researching about bioregional building materials. And we were lucky to, with BC Architects Studies and Materials, to work together with Assemble Studio from London in order to renovate and prepare one of those existing sheds into the new ateliers of and workshop space of Atelier Luma. So here the cool thing I think also is that our client was super involved also in the creative process, because they have a lot of knowledge about the bioregional materials that were all around. So it was a real exchange of knowledge about what is existing and what can we do more. And what, So the first thing again, we went looking around to the places that Atelier Luma already pointed and mapped, but also we went to different places with the eye of not looking for resources where you can have it in small quantities, but in bigger quantities in order to have this potential of making a lot of materials. So, for example, you see above, we went visiting different stone quarries, sand quarries where they have this waste. Most of the time in sand quarries they wash the sand, and then you have the waste of the sand is actually a clay muddy earth that has been dried and that is not been used, and so that was interesting to use as clay, but also the rice straw and the sunflower. And what was nice also with this project, so Assemble Studio been in the UK, BC been in Belgium, based in Brussels. We had to work together and find a way to work to. So we worked a lot through residencies. So we would go there for a week, 2 weeks, designing together, prototyping together, and then building small exhibitions in order to go forward. So those intense moments where you all together, again, like it was a bit like feeling as a community, was super important also to work together. And so it results in the end to this plan. So you have the existing shed and divided in 3 blocks, where you have above the longitudinal workshop room, and then down you have more the ateliers. So you see the models were also super impressive in order to take decision and to see also to try things out. And a lot of models on different scales, and on a lot of different scale, going to also prototyping in order to make decisions and see what would be doable or not. You see the construction site of the wooden element. Inside the construction site, and by the way, in 2 weeks the official opening is happening of the project. And here you see like the production of those bio-based materials with the rice straw, making acoustical panel. The whole existing stone building was insulated from the inside with rice straw, placed by local people there, an association. And then here the different, again the prototype of the ram dirt. And here, for example, BC Materials was as mission to work next to BC Architect and Studies to also create materials, mineral materials. So we actually did some ram dirt, the mortar for the ram dirt, compressed dirt blocks, so compressed dirt blocks and the mortar for the compressed dirt blocks, plaster, an acoustical plaster and a base plaster. And all with the resources coming from around. And one of the main resources that was super interesting to work with was the stone dust from the quarry of Saragon, because there they have this really beautiful quarry where it looks like a cathedral, where they cut this white stone, and then you had on the floor a lot of this stone dust, and this became the base ingredient of everything, and that's why you have this white color in the ram dirt and in the bricks, but it's actually not really common for ram dirt and compressed dirt blocks. Of course, we had to do a lot of testing to prove that those materials were good. The good thing in France is that you have some norms about ram dirt and compressed dirt blocks that we could follow also to prove to the engineers and control bureau to prove that it was through the norms and strong enough, even though it was everything inside, so much risk there was not so much. And we were super happy also to work with the best contractors. Here for the ram dirt, we work together with Atelier Cara from France, and that's a good thing also. It's this in France is that definitely in the south of France you have a lot of capacity, a lot of people that are very good in earth construction. And here you see for example, the reuse of the tiles from the roof, the clay tiles that were mostly reused also for the floor that you see the samples on the left, but also for the facade to create this plaster that is kind of crunchy plaster around the whole building. with these pieces of crushed, and then these beautiful cross-section tiles that became the terrazzo floor. Here you see the production of the blocks. Here, for example, BC Materials didn't produce themselves the bricks and the ram dirt. That's something that we could have been done, taking our machinery and go there to produce ourselves. But we trained a general contractor specialized in concrete in order to mix themselves the ram dirt mix that we pre-designed before and reformulated. Here you see the inside. So you see this whitish color, the plaster also on the straw bales inside, so you don't see the straw bales anymore. And then we also researched, that was super interesting, but the research ends to not been used, although now I think it's used in one of the block, but the research had to continue because we tried to make finishing earth plaster with algae as a binder. We discover actually that the algae, spirula, is not working only on for coloring, but also act like clay to bind actually sands together. But that was super interesting because yeah, it was giving really nice color, although it reacts completely with the UV, so it changed color. But when you have an artistic client, they like it also, so that was okay. But what was not really working really well was that the smell of it. When it gets wet again, then it would start to smell. So then we actually stopped a little bit the research of it, and then we. But now we found a way to get rid of the smell. So it's plaster in a few places. Here the construction site, the spraying of the earth inside. So yeah, that was super nice to be able to work with all those local resources, but also with all those local super skilled contractors, and that's what makes, I think, this project very interesting. Is that it's on a human scale. It had a lot of exchange. Also, we were lucky to organize a series of workshops also during the construction, not in order to lower the price or to have like free labor or this, absolutely not, but to exchange knowledge and to show that this unconventional materials has a lot of future in our building. So I think we reached also around like 100, 200 people that came through the different workshops, one on fibers, on earth, and on straw bales also. Here you see the fiber workshop, and that's it.
So thank you very much, Nicolas, for this marvelous lecture. Good evening from my side. I'm Gordon Selbach. Good evening, dear audience. Good evening, Victor and Nicolas. I think the last project you showed us from Luma was actually a great transitioning moment to what we'll be hearing from Rotor now, I believe, or I reckon. Because you showed us a lot of projects which basically see the bioregion as a source or is seen as a quarry for new materials. And I think Rotor is maybe more of a method, I'd say, where you'd see the building as a source or the building as a quarry. So I think this is what we'll be hearing from Rotor. So basically, Rotor is a multidisciplinary association based in Brussels, and we nowadays all speak about reuse. We speak about reuse in teaching. We speak about reuse in architecture, and everybody is jumping on that wagon. But what does this really mean in technical terms? What does this mean in terms of regulations? How do we go about bureaucracy? contractors, clients, the logistics of all of this. How does this truly work? I think Rotor is an association that truly has a massive experience in all of these terms, networking, the clients, etc. So I think we can all learn a lot from this system. From this system. So I will briefly I'll do a very, very brief introduction of Rotor, which is basically actually two departments. It's Rotor itself, plus Rotor Deconstruction, which was founded later on. But Rotor itself as an association was founded 2005 in Brussels, and actually since then has debated on questions related to resources, waste and obsolescence in the building sector through applied research projects, exhibitions, conferences, and very impressive publications. Some are actually here up front, so if you have some time, please take a view. In 2013, I believe, you curated the Oslo Architectural Triennale. And then 2014, so 1 year later, Rotor Deconstruction was opened, which basically concentrates more on the actual building audit, so basically looking at existing buildings and auditing them to reevaluate components, to then basically rework these components, take care of all these logistical issues, etc. We'll be hearing all of this later on. And I think a couple of years ago, I was able to travel with my students to see you, Victor, in Brussels, to actually see what this meant in reality. So large storage areas, the whole logistics of maintaining, deconstructing, and how that truly works. I think that's very, very valuable for all of us here today to really see how that works. So I'll just briefly also introduce you, Victor, because you've been heavily involved in the FCRBE, I believe, which has been founded a couple of years ago, 2019, which is, I think you will probably show us. Yes, Victor Messers is Parisian French architect, studied in Paris and in Tokyo, where we met for studies, so I think 13 years ago or so. You joined Rotor in 2014. And you lead research projects, consultancy missions on site, basically. You supervise reclamation operations on site as well, and you coordinate design and build exhibitions. So I think that's very important to note out as well, that you teach at École Nationale Supérieure des Arts Décoratifs in Paris, but you also taught in Royal Academy, correct, in London. So I think that's quite interesting to point out, that you basically span from reuse in teaching, but also that you're basically the guy on site looking at the components and seeing if they're suitable for reuse and taking it from there. So I'm very, very happy to have you here. We're very happy to have you here. The stage is yours. Thank you very much.
Do you want to read it? Yeah, because I need to do some exercise during the... I will propose some exercise, so I need to have my hands free. Hands free. Yes. Okay. Does it work? No, attends. Maybe up. Hello, everybody. Thank you for inviting me at this lecture today at the university. I'm really happy to meet all of you. Yeah, but besides, I'm still wondering why the Royal College of Art involved me in his project a few years ago, because I have a really broken English with my French accent, so, and like broken ears also to understand English sometimes. So don't worry if you don't understand everything. There is nice image. Voilà. So yes, I joined Rotor 10 years ago. After my study, I studied landscape architecture and architecture in Paris, and I run a small association called Sixième Continent, and I was like dismantling exhibition and trying to build something with this reclaim element. And then I met Rotor 10 years ago because I wanted to do an inventory of all the reuse dealers in France, and it takes me almost 10 years to achieve this goal. So now it's, I mean, like, I'm in a cross-section of my life because I checked this box. And tonight I'm gonna give you an insight of what we are doing at Rotor. It's not all the projects. There's not gonna be like exhibition that maybe some of you know and well known for these works, but as Gordon says, there's some books also about this exhibition. But I will try to do a really pragmatical talk about how to reclaim building elements. So, well, Gordon said that everything about Rotor, and like most of the students know. So we are a team of 30 people. This is a picture that was taken a few years ago, and based in Brussels. And me, I'm always like the black duck. I don't know if we can translate this in English, because like I'm here in the middle of the picture, but in fact I wasn't here. It's like a collage because I'm always in Paris, because I'm steering a small office in Paris of Rotor. So yeah, it's why it's a strange picture. This is all the branch of Rotor. So we have a design practice, consultancy, exhibition, research, and one of the research projects became a non-profit, cooperative company, which is Rotor Deconstruction, and we are dismantling and processing and selling second-hand materials. So the menu for tonight is in 5 dishes, and so we're gonna start with a brief history of reuse, and then ask how to evaluate the potential of reclaimed building elements, and then focus on the logistic, then the reuse actor, and the design projects. It's gonna be fast because the menu is quite dense, but yeah, I will be quite fast. So first, let's back in the time. During the Roman Empire, the practice of reclaimed building element was called spolia. Spolia comes from the Latin spolium, that means peeling off the skin of an animal. And if you look closer on this image, you will notice that each columns are made of stones, different stones, because they are coming from various cities that the Roman Empire conquests. And so the practice of spolia was to reclaim building elements as an expression of power. We found through archaeological studies that there was an existing market for second-hand materials during the Roman Empire, like selling tegula and imbrex, the tiles on the roof. And also, like in Pompeii, we found that much of the marble from the bar, it's the kind of the club of that time, was made. It's called a thermopolium, and it was made from the reuse of the tiles, from marble tiles from the palazzo nearby. This image was taken in 1884 in Paris, and as you can see at the entrance door of a reclamation yard, proving that at that time there was still a market for second-hand building elements. So Achille Picard was well known for one of these demolition companies, really able to reclaim a lot of building elements in his demolition company. And if you go through the newspaper, you will find that every demolition company at that time were reclaiming building elements. And you can see that on the top of the entrance, the pediment is in fact a piece reclaimed from the Palais du Louvre, a few years after the Commune de Paris, when the Parisians burned the city against the power. So he was able to reclaim some elements. This is an image of a demolition site in Brussels in 1928. So it looked like a bit like a recycling demolition site with piles of materials well stored, piles of cobblestones, the wood, except if you look carefully on this image, on this billboard, you will see like material to sell on site, that proving that less than 100 years ago, we were still selling on site the materials, and all the materials were dismantled to be carefully sold. And 50 years after, we changed our demolition practice for this kind of dynamiting buildings, and making impossible to reclaim building elements. So the question is why between Achille Picard and what happens in between Achille Picard and this practice of demolition, why we stop reclaiming building elements. So there is few ideas. One of them is few reasons. One of them is the evolution of tools. During the time of Achille Picard, they were using these hand tools. And then with the two wars, we got this kind of tools make more easier to knock down a building and faster. So you earn money if you demolish quicker nowadays, or if you build quicker. And also the cost of the labor rise up with the time. So deconstruction, the practice of deconstruction is labor intensive, like maybe like 7 times more than the demolition practice. So these reasons make change the demolition practice for the ones I saw before. And then after the 1970s, we changed our demolition practice for recycling. So this is like a demolition site that you know, maybe this building, famous building in London that was knocked down in 2017. And so we start to strip out the building to sort the materials and crush the concrete to make a new raw material. So recycling is, when we are talking about recycling, we are talking about crushing materials or melting materials. And we all know how disappointing could be this practice and a great loss of value or great loss of energy embedded in this element. And if you go through the demolition permit in a year, like in this image of one of my students in London, she cataloged like thousands of demolition permits in London in 2018. You will see that there's like various type of demolition, but in all of them, only 1% of building elements are reused following their first applications. So it means that 99%, the title of this lecture, are materials that are going to the container, or the best for them is to be recycled. So the question is how to facilitate the circulation of reclaimed building elements. So now I'm going to propose you a small exercise to warm up a bit. It's an exercise that I took from Denis Meadows. You maybe all know his guy which wrote the Limit of Growth report in 1970s. It's an exercise to interrogate our habits. So please cross your arms like that. And look which hand is on the top. Now you uncross your arms and try to cross in the other way, in reverse. How do you feel? Good? Difficult? No? Not natural? Yeah, it's hard, I know. It's hard to change your habit. And it's the kind of feeling you can have when you start to build with second-hand materials in a world where everything is made for new materials. But trust me, if you try every day to change your hands like that, to cross your hands in the two way, you get used to it. So this is the good lesson. So at Rotor, we try to make tools to help you to don't have a nausea each time where you change your habit and to build in a different way. So I'm going to present you, like in this chapter, a few tools at few critical point of the project. So the first question when you want to reuse building elements is about the assessment, how to evaluate the potential of reuse element. You have a site like this one in Paris. It's a former military camp, and it's transformed by Paris Habitat into social housing. And you want to evaluate the potential of reuse on site of these building elements. So the first thing is to do a listing, like you can see that the students did here, a listing of all the building elements, but an element that can be dismantled is not an element that can be reused. There is more criteria to take into account. Like for instance, is there pollution, the toxicity, like lead, asbestos, the quantity of materials. If like 2 square meters, it's not going to be really interesting. The state of wear. Is it in good condition? The price of the market, the price in new. Is there an existing reuse actor? The phasing of the building site, if you have to remove quickly before, the accessibility. So all these criteria are required to evaluate the potential of reuse element. And if you look on this reclamation audit, we sort the elements in 3 categories, and this one are the more plausible, the more easy to reuse, because we know that there is a reuse market. So even if we don't want this element in our project, we can give to someone. So we put like, okay, category A, the most easier. If you're lazy, do this. If you're more ambitious, there is other materials. There is no reuse actor, means that there is no market, business market for this element. But there's a large quantity, good quality of materials, so we can do something tailor-made on site, for example, and then the anecdotic. So this is like an image of the information that we need to communicate to the actors of the project. Because as designer, if we don't show the information, we cannot manipulate it. So it means that we need to create the tools to make visible these informations. So these are the candidates selected to this after this criteria. And then we needed to go a bit further to convince the architect to reuse them. So for instance, there was this cupboard in wood. And the question of renovating this cupboard, the first question is about the surface treatment, how to sand it, how to treat them. So we did some processing tests. And then the design, because they are not square, there is like bending, etc. So you need like a design that accepts this element in new furnitures. And we did some mock-up that the architect put in his project. Same thing for this partition, toilet partition. It's like kind of trespass panels. It's really high. It resists to high temperature, numerous of chemical products, so it's like really hard, a really long lifespan. But the thing is, the environmental impact is really high for this kind of materials, so you have to reuse them. So in fact, it's a good board for carpentry, and so we design a stool. So we upcycle, as we say, like we give another value, more value in furniture than in a panel. And like with the CNC, we cut these panels and create the furnitures for the cafeteria. Everywhere in Paris, under the roads, there is this kind of cobblestones. So we discovered that the city of Paris got a platform where they cut and treat these cobblestones. So they were able to cut them and to have like a plain road for a pedestrian and like rounded one for the garden. Same for the cast iron radiators. There was 300 pieces, and there's a reuse market for it with like a high level of services and a warranty of 10 years. In fact, so we were like astonished about like discovering these traders. And then they put again in the project with the new hardware stuff. But it could be a nice story, like everything is reused. But in fact, really, really few of what I show you were reclaimed because of the organization on site. And for example, these sanitary were damaged during the deconstruction, so we cannot reuse them. This lamp were meant to be transformed with a LED system, but the engineer didn't accept it because he cannot calculate the reflection of light of the abat-jour. This railing were dismantled to be transformed in urban furniture, but the company put this railing at the recycling 2 times, maybe to have like a bit of money. So like we understand that there was a lot of step or organization on site that we didn't take into account, and make not possible the reuse of building elements, as these 4,000 square meters of wooden floor that were polluted by the lead depollution operation. So we came with this question of the logistic. Reusing building element is not only assessing and transforming it, designing something, it's also about logistic. So how to extract building elements to put them on track. Yes, this is an image of a castle in France, in Burgundy, built 20 years before. Start to build 20 years before, so it's already finished. And the question is why we are building again castle in France, not for making war with our neighbors, but because it's a research project, in fact. And these people were like historians of art of the 11th century, and they were like studying how to build castle at that time, and they were fighting like how to make an oven for the clay, for the mortar, etc., like that. So they make like 10 ovens. They use the tools and the stones of that time, and they make a castle. So you can see like this guy crushing the stones with his hammer and like puff, puff. And so this is a really pragmatical approach to solve historical issues, and we did so, and we built our castle in Brussels, and opened a deconstruction company to get the hand on site. And so we start to accept this kind of mission of just before the demolition, coming here and taking out some building elements, for instance, these ceramic tiles. So we needed to test some dismounting practice. So here you need to crush the first row to have access to others. Some of them are broken, so maybe you have like 30% of loss. So you know that you cannot reclaim 100% of materials. And then you're faced to how to extract the materials. So you need to think about the right containers for the workers to extract by the door or by the windows, etc. And then you have the material that comes like that. So you cannot sell these tiles with the mortar. So you need to try some processing by hand, but it's too long. So with like a vinegar, like pouring in the vinegar 20% for 1 week, and then you have like this new ceramic tile coming out from this treatment. We found out the culture embedded in this material, so the catalog of that time to know which pattern you can do with it. We framed the state of wear, like category A, B, and C, like the A without scratch, the B with like maximum 5 millimeters. It's like your phone on the second-hand website, you know, like you can buy some. And then we start to sell this element, and some designer bought it for their project. We collect also like sanitary and start to process them and sell them. Also, we collect also like contemporary building elements, like this radiator cover made of plywood that all the designers in Brussels really love, because you can like transform it in many ways. We collect like glue lamp beams structure to make furnitures. And then we had like a first catalog of building elements to work with second-hand building elements. So that was like, I think, another step in our practice to have access to this catalog. And we make a shop open to the public in Brussels. So you're welcome if you want to make gift for Christmas for your family. You have nice lamps. And Rotor Deconstruction try to be as possible as close as the services of a new product to make it easy for everybody. So this is a challenge. And I think something in common that Nicolas said before, trying to reach the same services. So this is a challenge. And for instance, we are now proposing also to sell products from other demolition company and not from our building site as a depot vente. So like you bring the materials, and if we sell it, you have like half of the sale for you. it means that we share the risk of the money invest in the workers, because you have only the money back when you sell the materials, so you need to invest a lot of money for all the time of labor. So we discovered that we skip this step during the production of material that is really heavy environmental impact, and also the waste treatment doing so. We discover also that we create like a lot of jobs doing that, and we conserve also like the culture of the materials. But the next question was, is there other people doing the same thing, collecting building element on demolition site? So the next chapter is about the sector, how to get reuse element. And we took another pragmatical approach for that, and decided to drive 1 hour by car from Brussels and to look on the countryside where the land is cheaper than in the city, if there is some people who stock materials. And in fact, there is like this kind of company everywhere in northwestern Europe, and I'm sure there is in Austria, that are selling second-hand materials. So there's various profiles, like antiquity dealers, traders of cast iron radiators that we saw, demolition company that stock their elements from the demolition, startup from a new generation. And so it's not, most of them is not the green revolution 2.0 that you were expecting. It's more like that, like this one in France, authenticité, caractère. So it's like interested more in the patina and the story of Marie Antoinette than the circularity. But he got a huge catalog of second-hand materials, like this board that he reclaimed from various places. He got a stock, so you can design your project, and 6 months after, be sure that they're going to be like some wooden board. Maybe it's not the same one that you see at the stock, but they're going to be some. He proposed also some services to treat the wooden board. And he sells some of them in London, in Cambridge, to 6A Architect in this new facade of dormitories, like proving that there's no problem to add some old materials, antique materials in a contemporary project, and fit perfectly with the design. So we discovered that there was brick specialist selling brick, second-hand bricks for houses, window specialist selling like second-hand, double, triple, simple glazing, and even this type of antiquity dealer able to build the frame of simple glazing windows for a really complicated building project, which is a building of the European Commission. So like a kind of public tendering, really intense. And the trick here is to dissociate the constraint with the insulation is inside the eggs where our minister go every month. And the facade is just simple glazing for the rain and the wind. So it's kind of an inspiration for the passive house to reclaim simple glazing in this kind of device. And so we had like a second catalog of materials, a broader, with like a lot of company everywhere. So there is not all the materials you want, but you can start with that. You can start with the state of art to change your practice. So we decided to do an online directory called opalis.eu to give access to the information of this reuse dealer. It's not an online marketplace. It's just a directory. And we give information about like some project that already did implement reclaim building elements. And we went a bit further in this FCRBE project, which is means like facilitating the reclamation of building element. It's a European funded project, and we developed some like material sheet about the most common materials that you find on the market, guides to help to extract building materials, guides to manuals to implement building material with all the tendering, public tendering, all these Rubik's cubes of spaghetti stuff. And so you have like this website for Northwestern Europe called opalis.eu and SalvoWeb for UK. And yeah, I invite you to do yours in Austria. The last chapter is about designing. Of course, we'd like to see a bit of a project that implement and test this practice. So I will give you like a few lessons through different projects. So like for instance, this first project is about, the lesson is about consult the sector to formulate reuse objective. So we've got this demolition site, an old building in Strasbourg from the beginning of the 20th century, full of building elements that you can find on Opalis. So we did this inventory and reclamation dismantling test. But the question is, when you have to write the specification for your tender, which element you're going to put in it? Which one you're sure is going to be reclaimed, and which percentage of it? So to do so, we call all the reuse actor. We send this inventory to them to collect their mark of interest. Are you interested of taking this tile, this beam, etc.? And so with their answer, we can have a reuse rate in our specification and say we want, we oblige the demolition company to reclaim 80% of the radiator, 50% of the wood, etc. And that was, I mean, that is really helpful because otherwise you only wrote like, we'd like to do some reuse, but do the best effort. And they say, I did my best effort and there is 0%. So, and then the demolition company accepts the tender, start to dismantle the element that we are sure to be reused and call this, again, it's like website of the 90s, you know, it's not like startups, but this one in Netherlands, not so far from Strasbourg, is like really, really efficient, and send a truck and bring the tiles in Netherlands and sells them like from Strasbourg, and another dealer take the wooden beam, and at the end we have like 50 tons of building elements that were reclaimed on this demolition site. Second lesson, adding new elements to make it work. When you reclaim, when you reuse a building element, you always need to add a small piece of something new to make it work. So you're going to understand. So it's a electronic music festival in Brussels that invite us to cover their event, to have like a big roof, to build a big roof with a really few amount of money. And so we went online to check what kind of structure we can have for nothing and that can cover a space. So in Normandy, there is a lot in France of greenhouses that you can buy. So we bought 3 of them for nothing. We send our guys. So this is like a deconstruction site on the weekend. Which one was quite sympathetic. It's kind of architecture in reverse. So you need to understand how it works and which piece you have to dismantle first. You need to do some dismantling notice to remount after. So you need to note the pieces. And we send the truck and install in the festival. And so we needed to add a piece of new materials to adapt to the site. So if you look at the site, it's like this. And this light gray pillar are the new pieces that make possible to add this roof on this scene, and also to rise up a bit the roof to have this event. So we needed to add like this part of the pillar and also a new roof to make it work. And they can add for the whole summer their party. Another lesson, keep in touch with your network, means that you need to constantly call or be aware of what's going on in your city, which demolition site, who is doing what, if you want to have access to a lot of materials. So here we are close to the European Commission, and Antonio Parodi, the owner of this boutique, wanted to open a library, a bookshop in 13 languages, the same book in 13 languages. And he wanted to invest 100% of his budget in handwork and no materials. So like for him, like reusing building materials was the way to invest in human and not materials. So we start to do the project and check what building site, demolition site we've got. So at that time, there was like the demolition of this bank that was built like 40 years before in Brussels, full of golden nuggets of precious materials like these flame granite walls, cladding, etc. So we collect a lot of elements from there. In Ghent, there was this book tower renovating, and they were wanted to throw away this shelf, and they call us and say, do you want to reclaim this shelf? We say, okay, we come. And we did some research, and we found out that they were like fit perfectly to their space, tailor-made, and it's a famous designer who did the same in the American commission of je sais plus quoi. And at the end, we tell them like, but what you gonna put in your, what kind of shelf you gonna put in your renovation? We don't know, because we have the perfect one that fit perfectly for your space, and it's made from a famous designer, is the one that you give us. Say, in fact, and in fact they bought again this shelf. So, and we keep some of them for the project. That was the tax for ignorance. Sorry for. I hope it's not recorded. No, and so we collect like all these building elements, and voilà, avec this insulation panel, we made some like bookshelf, etc. And so, like you have 100% almost or 90% of reuse element in a shop, and you don't see that it's coming from a second-hand. So the floor, the lights, etc. And we had like one operation to do, one design project, one design to open this wall and create this blue cave for the counter for the guy. And so we didn't find a wallpaper, so we were like, okay, we're gonna paint it in a color because it's gonna be cool like that. And at Rotor, we're really bad when we have to decide for a new material. So we check all the blue, all the kind of blue. We have like arguments about, no, that blue is like too realist, this one is too, etc. And one of our colleagues saved us and came to the theater, La Monnaie, and he's scenograph, and he checked the guys from the scenography and say, but we have like a lot of decor that we throw away. They are in the containers, but we throw away because we have too much of them. It's a piece of art. We say, so can we reclaim some of them and reinstall in your shop? Yeah, of course. So with like a couple of bottles of champagne, we give them, and they came and installed the best wallpaper that you can ever had coming from the theater. It's almost done, but design with flexibility, this is maybe one of the major lessons that you have to take into account. It's like designing with reclaimed building element means that there is a lot of uncertainty in your project, and you need to have an open frame to accept this uncertainty. So maybe a lot of you know this project, and during that day we saw it. It's in Brussels for the non-profit organization called Zineke, which is doing some parade in Brussels, and they needed like this building for their workshop. So during the renovation, there was an extension of this facade. So creating a new facade means that you need windows. So we meet this reuse dealer of windows, and that one is really nice because he got a huge catalog with all the quantity and the dimension, so you can work remotely. And so we designed this, we start from this catalog, but the first step was to give a permit, for a construction permit to the city, and how to be sure that the windows that we saw in the reclamation yard going to be the same 6 months after at the starting of the building site. So it was not possible, and we had to design this flexibility and say to the city, like, the opening going to be maximum this wide and minimum this wide. And with the later, of course, it's a backyard facade, not in the street. And so they accept it and understand that we have no choice to do so. But that was like a kind of a good lesson to frame this incertitude. If you know the word in English of incertitude. Okay, thank you. And then second step was the specification for the contractors. These contractors going to buy the frame, and he's going to be in charge to choose them. So we needed to frame also this selection and say, okay, we're flexible about the color. If they are pink or blue, it's okay. But we want an homogeneity in the batch of the frame. We want energy efficiency, of course. We are okay to accept some little scratch, and the dimension could be like this wide, maximum or minimum. So that was another way to describe to the construction company. And when the time to build this facade and to buy the windows, and this is kind of work you have to do when you want to reclaim, to install, implement second-hand windows, to draw all the windows, have different facade and present to your clients and say, okay, we select that one. And in fact, we build this facade with these second-hand windows. Last lesson is quite obvious for everybody, but I wanted to show it, reveal what's already there. We are always like hearing about this, but this one is kind of poetic and maybe go beyond what we can expect. And we're in Ghent, and there is this former industrial harbor, and the architect wanted to transform it to a public space, and to do so they paint everything in white, and we were invited as like 1% artistic to do something on that site. And we say to the architect, before painting, can we go to the site and check what is already there? Because maybe there's no needed to paint everything. And so we come with like my colleague, which is bioengineer, and he's a big geek of mushrooms, and he take picture of all of the mushrooms and say like, this one is here because we stock this kind of material, this one here because of this climate, etc. So okay, there's a nice story. So we keep one of these mushrooms. And then another one, like, wow, he's like he likes curating exhibitions, or like, okay, I'm going to select the graffiti because this one is nice, etc. And then another one say, look at this coloration of this sanding of this concrete that reminds the past stock of the elements here. So okay, we frame here. And then we let the company paint everything. And instead of having a public space, they had like a gallery, an art gallery. Voilà, and less painting. Merci.
I think it was incredibly inspiring for us. Yeah, I think I'm fine. We are going to be 5 people here, so please join me on the stage. And then maybe we need some background, which is not favoring one or the other. No, incredible. I mean, I thought I read a lot about your work. I've seen your work in exhibitions. You know, I read interviews and so on, but it was very different. Also seeing your energy and passion, how much you want to share and how much you want to really going from this niche into the mainstream. And I think this is an opportunity today to somehow inspire more young architects or future architects to somehow follow this path, I guess. In order for this to become a symposium and discussion, we would not like to start with the questions from our side, but we would really like to open it first to the audience. So please don't be shy and please ask our two experts here whatever is relevant for you.
Hello. Yeah, for a question maybe for you both is like, how much do you depend on carbo-intensive industries for your work? Like, how much do you depend on carbo-intensive industries? Like, for example, for you that you use the byproduct of sand, which is probably produced to create concrete, and like, how would you think, is it possible for you to be independent of these cycles? Yeah.
What do you mean with cargo?
Yeah, like carbon emission.
High carbon.
Yeah, yeah.
Is it working? Yeah. Yeah. Okay. Well, I think
It's better? Yeah, okay. Well, in our field, I think we are not absolutely not dependent, because there is plenty of earth that's been excavated. So this is like, let's say, waste. And what it's actually also cool, I think, is that we see that one of the biggest issue that we have with our material when we start to calculate the carbon footprint of our material is transport. So from the moment you transport too far the resources or the finished product, and it's quite heavy, earth brick, it's the same density as concrete. Then it loses completely its sense. Then it's sometimes even more sustainable to use a cement brick or a fire brick that is more local than an earth brick that is coming from further. So there is this logic of working locally, what I like a lot, because then you are pushing also to have more local actors working, and so you have more healthy competition, I would say. There is no competition because actually everyone is working in his fields and being connected by a network also. So I think it's even a plus point, I would say, that this fact of transport that would limit ourselves to be carbon intensive, that it helps also to have to be local.
To add an answer to that question, as you see on my presentation, we always need to add a new part to make it work. So it's kind of idealistic to use like 100% of reclaimed building elements. So you always need to combine with something new most of time. And we had this discussion this morning about the vertigo that you can have, like working with like counterculture or alternative, and but dealing with the existing business market. But in fact, I realize when you are counterculture and like too extreme, nobody works with you. So you have like no impact in the society. If you go too far with let's say the devil behind your question, maybe you lose your soul also and you don't solve any problem. So you have to deal with this ambiguity and this realistic world of dealing with a bit of new, a bit of... but the question, I think, to reformulate the question is like, what kind of an economy do you want?
How does the bidding from the companies work when they are not in the local region or further away than 60, 70 kilometers? How do they bid only in the near region, or how does this work?
When they bid for a construction.
Yeah, that when you have a project and you want the building companies to bid for, but you only want the nearer companies and not a company 200 kilometers away.
How do you make sure that they are within the radius? Yeah. Okay, now we understand the question.
It's really precise questions. You're like super professional of this topic, so yeah, I'm a bit disturbed, but so I'm gonna maybe answer a bit of your question and go a bit beyond, but it means behind your question is a question of locality. And as you said, like going too far with your elements is nonsense. When you're reclaiming building elements, some elements can go really far, like the Trespa panel. You can send them in America, and the CO2 embedded in this element is like so high, so it's gonna be okay. And like for stones, you can maybe drive 200 or 400 kilometers, and then it's nonsense. And so, but the question is, it's already super difficult to work with second-hand materials, and so you don't have to limit yourself to be really close or really ultra-local, and accept that the new materials are coming from China, from India, from Brazil. So if your company is coming from maybe like 100 kilometers or 200 kilometers, for the company, I think it's not evident to work like that. But I would accept it because I prefer to have someone who deal with this question of reuse that locally nobody say like, it's too complicated, so I don't answer. So at the moment, we need also like to have like kind of a big range of activity to don't limit yourself because like few people want to work in that direction. I mean, it's part of an answer of your question.
Do you want to extend? No? Yeah, I think what it was interesting to see from both of your lectures exactly in terms of the transport and locality, how far from the construction site the company or material comes from. It's really important to acknowledge that while you're doing bricks or creating bricks, it has been historically relevant. It was close to the construction site. So the whole Vienna has been built by bricks from the Vienna clay, no? That was inherent in the whole idea. And I think we are forgetting about this. Of course, sometimes transport within EU makes sense because it's not that far. But I think we really don't know. I didn't know until I went to a quarry in Istria that just the new director decided to limit the sale of the stone to the Saudis because certain amount of stone needs to remain in Europe. So basically it's this kind of, strategy of the owner of a quarry that decides either this becomes a local European or a local business, or it becomes a global business, and within which it's even useless to address the idea of CO2 for the transport. And I think what is extremely interesting that we are, as you showed in your lecture, we are going back to where it was normally that we need to primarily build with the materials that they are in abundance around where we are dealing with, I guess, no? So this and maybe from the transport, going back to the public, I just wanted to ask another question because it has been coming in and out for a very long time, and because of this kind of Brussels agenda and all these kind of public buildings, EU public buildings, it's the standard and the norms that you actually opened up also with DIN standard, French standards. What did you learn within the Luma atelier? What did you learn with all the previous projects? How do you approach? Because once you want to go from niche to mainstream, this is one of the key moments that you need to address in order to become mainstream.
Yeah, that's completely true. It's we see that from this mission of trying to bring it to a broader amount of people, you have to have all the elements in your pocket and proving that your materials works. It's one of the important thing, and then you don't have like European norms on earthen construction, so we have to do a lot of testing that are this kind of experimental norms that you do yourself, but they become, I would say, like almost this kind of marketing tools in order to just to give guarantee to everyone, because of course not everyone wants to take all the risks, so it's important to have them. But I see also that you can also build without norms. I mean, it's with common sense you can also do it. And I think it's also, if I would have thought from the beginning before Burundi, I'm gonna follow actually just the rules in order to build, we would never be doing what we're doing now. I don't say that everyone need to take all the risk, but sometimes you also have to dare to take some risk, because otherwise we're not moving forward, of at least being critical. So what's like daily work for us is we convince, let's say, an architect or our clients to build with earth bricks, and then the engineer say it's not possible. And then it's like, okay, and the engineer said it's not possible, and then you start to say why, and then they come with calculation, and then that's your work to understand the calculation and the logic behind, and then to reframe, no, you're wrong because of that, you didn't take, yeah, that's true. And it's, you really have to go through and be critical through all the critique of everyone, because the most people always try to take the most easy path. So that's the thing, and that's why I think the having guarantee and following norms is part of it, because then it helps to have more arguments and to go faster to your goal. And it's difficult, because we see that the industry, the big industry, like, I don't know, concrete industry, they have so much resources and they can just go so much faster if they want to get norms, to get the thing done and approvals, and because they have a lot of resources in the back. And so that's a bit the thing, is that we're going more slow. So that's sometimes a bit a struggle, but yeah, we manage.
No, I think it's important that you mentioned engineers. Of course, we know exceptional engineers who are willing to take the risk and who are calculating with new materials. But we also have to acknowledge that the majority of engineers works with softwares where they select the materials which are already a part of the palette. And if you are not part of the palette, there is nothing to calculate, because they don't know how to calculate otherwise than with the software that has been priorly provided. Similar goes with biophysics engineer, but that's a longer story. Do you want to expand?
Yes, of course it's a problem, the warranty, the norms, but as you said, like really few of norms are mandatory, and like a lot of them are just you take it or not. But if you take precisely an example like ceramic tiles from a swimming pool, you reclaim it and you want to put it on the wall. In fact, you don't care about the sliding resistance of this. You just care about does it fit on wall or not. And in fact, when you look at the fitness for use of the building element, but all the problems collapse, and you say, okay, we just need to secure this information or this one. Sometimes you find back the sheet of the product. Sometimes you can add a new product or a new treatment that give you this performance. Sometimes you can downgrade, downcycle the elements for something less with less effort on it, or you can upcycle it to something with more value if it fit with it. So if you look the context, what kind of material for what kind of use, and you interrogate what are the risks, what are the issues, and you can deal with your insurance saying, okay, I manage the risk because I find this sheet, this material is coming there, I put it on the wall. And in fact, a lot of building elements from second-hand building elements can be insured already, and like they are already doing this if you give them these informations. So for some, a lot of like interior finishing or stuff, it's not a problem. And even for structural elements, like there is a famous project in London called BedZ, maybe you know, like Beddington, like built in 2001, and 95% of the steel beams are coming from the reclamation of like a train station. And to do so, the engineer wrote the specification for the selection of the steel to have no problem. As they say, we need to select the steel that are dated after the 1970s because it's a harmonized regulation. No marks of rust, no fire in the buildings, no beam installed in a bridge or whatever. And if you check just this information, you can select materials that fit for the use without having like test or whatever. So in fact, you can already do a lot of things if you look carefully to the use and the materials.
Other questions? Yeah.
Yeah, it was actually a question if you.
To them?
Yeah.
There is another mic.
No, but it was actually a question if you work with load carrying elements, but you just answered it.
Okay, the next question further up.
Thank you. My question is more on the technical side. So you've mentioned in the earthen bricks and the rammed earth that you use the binding materials, the different ones, and you've tried out the algae, you've used the clay, but what other binding materials did you use also for the self-made mortar and plaster in the, especially the Luma project, for instance?
Well, we tried to use as much as possible clay as a binder because from the moment you use clay, you have this fantastic property that you don't have with any other materials on Earth, is that you can actually reuse the material, recrush the material, putting water. So for example, you make an earth brick over earth plaster, and you scrape it down, and then you tear this brick down, and then you put again water, you put it in the same formwork. You don't have to add any resources in order to make the same brick with the same performance, exactly everything the same. With wood, it's not possible. When it's rotten, then yeah, it's not a beam anymore. You have to wait that the tree is growing. With aluminium, you have to weld it to fire it to 800 degrees again to make a new element. With earth, it's actually through the clay with this fantastic property of being reversible. That's make actually the most circular building material that you have. So for us, we try to focus as much as possible on clay as a binder, because it's really incredible. In cement and lime, for example, you don't have that because you have this chemical reaction that will make that it's hard. And then if you were to recrush it, you would have to put again lime or cement in order to redo the same brick with the same performance. So you have to add stuff. So for us it's that, but I have to say that we see that in order to also being able to quickly go towards like a growing market and having more impact, that with certain products we decided to have like a bit like an in-between phase. And so we have compressed earth blocks, for example, the one that we're doing with the concrete factory. We stabilize them with cement, 4% of cement, what makes that it's possible to recrush it, but then we have to put again 4% of cement in order to redo the same brick. But this cement is it's not helping for compression strength. It's just helping for two things, and the one thing is and that's really funny actually, the one thing is actually the corner strength. So when we transport a pallet of brick to a construction site, it might break the corners, and people, when they pay money, they would like to have a brick that is perfect. So that's one of the reasons. So if this changed already in the mind of people, then we could could be helping. And the second is also water, because of course, yeah, clay is reversible to these binding properties, but it's also because through the water. So you can imagine that if you put a brick in water, a mud brick in water, then it will become mud again. And then you can reform it. So we put this 4% of cement also to be able to resist a rain during construction site. That's also one of the reasons. You know, in Belgium we have 1 month of construction site holidays. So what happened a lot is that it's raining on the construction site, and so if I think we see that on the construction culture now is not yet ready to have this. These earth bricks, but on the other hand, we produce with this fired brick company the molded earth blocks, and they are like 100% clay based. So those, they are more like, let's say, the radical bricks, I would say. They're also super strong, but if it rains on it, then it becomes mud again, and the corners are not sharp at all. But you can make perfectly walls, also load bearing, etc. But we saw that we needed to create also that block, that bit like the compromise block, I would say, in order to already introduce earth as a building element to the construction sector, in order to slightly go towards a radical change.
Thank you. And maybe one more question regarding the mortar and the plaster and the waterproofing of the bricks. Were there any other ingredients, maybe waxes or other types of sealers that you used to waterproof it?
Well, no, we try actually to not use that, and try to promote as much as possible earth inside the building where you don't need to seal it, because all the sealers, it's difficult to keep them breathable. So if sometimes we can use some silicates in order, or like methylcellulose. Those are like the typical one, in order to create a little bit of extra of binding, but also some viscosity in order to for the applying of plasters, for example, to make it more easy. Those are a bit like I would say the secret ingredients, although it's not secret at all. You can find it everywhere. But we try to use them as less as possible, because you actually don't really need them. They are costly. They are processed materials. So we try to use those as less as possible. Yeah.
Thank you.
Hello. I have 2 questions. One question is, in Germany now there is a new DIN norm that you can build with earth bricks at 4 stories high. How is it in France? Is there also,
I'm Belgian, so so in France.
Belgium. No, because you were speaking also about France and the DIN norm and the earth.
So in France they have ATEX, what does it stand for? Norme expérimentale, agrément technique expérimental, something like that. So they are not so far as the DIN, but we can see like that the new ATEX, for example, the new French ROM, it's written quite the same way as the DIN norm. So I have the feeling that finally German-speaking communities and the French-speaking finally started to understand that they should write the norms the same way, because maybe we will once have like an European norm that would be able to harmonize everything and go to like a EN. That would be the best. But for the moment it is not, and in Belgium it's even worse. We don't have anything, so we just saying something. But that's also nice, because then sometimes we use the DIN, sometimes we do the ATEX when it comes.
Same is for me. It's beautiful.
No, it's interesting.
Use the one that we like the most.
I wanted also to ask you, which DIN, which norm do you use to assure your products that you sell, for example? Also, how do you work with these norms? Because you have to, if you produce these products that you, the one that you mentioned in your slides, you sell them, and you also give the guarantee that they will work.
So actually we do the whole battery of tests in order to come to the certain, for example, for the think it's in 245 limestone. I think that's this one.
Yeah.
For blocks, then that's the one that we following in order to give a certain strength class to our bricks. But yeah, I mean, that doesn't, we declare that, but that doesn't say anything, because even in Belgium, because we don't go until Germany to sell our blocks because it's too far. So okay, it's some people are convinced by that, but most of them not. So we have to go through this ATG, it's called in Belgium, Agrément Technique, goedkeuring. It's an abbreviation in both languages. But this is actually, it cost us no money to prepare that, because that will help to give a guarantee in order to help selling the blocks easily.
Yes, but I was also thinking that it would be great if in whole Europe there is.
Would agree on that, that's definitely.
Okay.
But although also about load bearing, I think also for me, we have as an architect always this idea that we should look only to load-bearing solution of materials that can do everything. And I think earth, okay, it can carry some loads for sure. You can go to up to 3 stories, but the more that I think about it, I think that it may be not so interesting to make load-bearing construction in earth, because imagine like a nice wooden structure where you allow more flexibility, a plan that could be with columns where you have over time also more flexibility, and then having an infill with that are more mass, because wood is quite light, and so adding inertia by putting the earth being one of the most dense material with such a low carbon footprint, that's for me having more sense. And so then you don't need to have any loading capacity. Yes. So in the same way you take less risk also. So for me, I see more potential in this kind of construction.
To mix these two.
To have smart use of earth and wood, or even
It was also interesting. Sorry, then I finish. That you said that rammed earth doesn't make sense if you have to. Sometimes it's better to use bricks, because you need a lot of effort to do this, and there are not so many people that can afford it, and I also think the same way, because rammed earth construction is so famous now, but I think the brick construction is really very
rammed earth is fantastic material, because it completely changed the image of earth. That's also through the pictures of the house of Martin Rauch that I was like, wow, it's so nice. I thought earth was only for hippies, and no, that was what I was thinking, and I was like, oh, that's beautiful, we can do contemporary architecture, but by actually taking the time and going more in detail, and I saw that there is also a certain limit to that material, and the biggest limit is that in our Western countries where labor is so expensive, you arrive with a wall that is 40 centimeters, that costs around 1,000 to 2,000 euros a square meter, and we have to insulate it, so you have to choose one of both sides where you have to hide it. So then you start to think, and also for the facade, you have this erosion, so it's a lot of work also to convince your client that it's normal, that it's actually falling down bit by bit. That's part of the process. Don't place. So then you start to think, is it really worth it to do all this convincing, when you see that there is so much potential to use earth inside the building? And if you look to the mass of a building, the facade, how much is that? It's maybe like, I don't know, 5 to 10% of the total weight of the building, even less probably. So there is more potential inside the building to put some earth.
I agree, because sometimes they ask me to repair the rammed earth walls, and I know this problem.
It's possible to do,
It's possible to
but
do,
it's
but
not so easy.
Okay. Thank you.
Another question over there. And then I would like to later ask you to question each other. I think I would be great too.
Yeah, thank you for your very interesting input. And I would like to ask if you reflected, or how do you look today back on your project in Burundi regarding discourse on decolonialism?
Yeah, very good question. It's for me, it's very a struggle, you know, because we did this project, and if I would do it again, if you ask me, do you want to do it tomorrow? I would say no, that's for sure, because yeah, for young male architect going to Burundi thinking that they will do something, it looks wrong. I have this feeling also, but on the same way, I feel a bit like in a dual thing, because I have really the feeling that we learned so much by doing this project, so much from the people there, so much from doing stuff there, failing also, doing it again, and that became also like the base of a lot of work, of concept and practice, or of how we practice now architecture, that it was so meaningful for me and for my colleagues that I don't have the answer straight. So after Burundi, we did a few projects. Before COVID, we did, I think, 4 or 5 schools in Morocco, where you could again question the idea of decolonialism, and why would you, as a white architect from the Western, going to teach people how they should work with local materials, what they do actually for more than decades. But again, we did that with through university also, in design and build. And then you arrive with young students that were as naive as me 12, 15 years ago, and they learned so much again, then that you feel that there is this really valuable thing of learning. But what are we giving back to them? That's a good question, and this is what we're now trying to do. So after COVID, during COVID, we couldn't do project anymore in Morocco, and then after COVID, now we went back, and then now we are doing workshops in a specific village where we built it actually first a school, then a women's center, and then the students that did the women's center, they actually built 2 other women's center, and that was all before COVID. And now we, after COVID, we have this feeling that we really know the people there, and we built a kind of trust and relationship, friendship also with specific people in the village there. And I feel confident now to go back to that specific village, to continue to organize workshops together with them, where these super skilled people in Ram Dirt and Adobe and other local materials can teach our students, and we can also come with more theoretical background and explain about earth construction, and also now that it's more like in a workshop format where we don't build a building anymore, but we just renovating the existing, and so that works for the moment better as a setting for me, because you have this value of education that I see a lot by going abroad, going far to completely be out of your comfort zone, and then to be somewhere where money has another value, and that helps you so hard to be thinking out of the box. But I think by not building something there, but then just being together and talking about construction, having hands-on experiments, that's where now we are stopping, and maybe we're gonna build again there. I don't know, but not super soon, I think.
Thank you for this answer. I think it's brilliant. I think forging long-lasting collaborations and exchange of knowledge and sharing knowledge, it's also something that you mentioned before. It's if we want to advance, I mean, if we know what we stand and what kind of collaboration we are doing with remote countries, it's very different than coming there and implementing our mentality, our processes and our materials. That, yeah.
Oh yeah, if it's okay. I would just have a question for Victor, like regarding establishing these reuse strategies in the mainstream. My question would be, if we, what's your experience in reusing, like for example, these tiles and windows that you showed in your example regarding the problems which we discussed before with the how we are in such a labor, like in a country where labor is so expensive, and yeah, how does it compare to put out all of these materials, which seems like a more or less labor-intensive task, regarding like monetary expense of doing this, and also like the CO2 expense of bringing it maybe to another facility to treat these different materials. Yeah, so how does it like compare against using new materials?
But if you want circular economy, you need to accept the criteria of this circular economy. It's not cheaper than new materials, except if you are unemployed and you have time, or you have time for yourself. But circular economy is much often like more labor-intensive work, and it's why it's good also. So it's not an argument that says that it's cheaper compared to new. But what can you compare as a new materials? If you take a cobblestones, a pavement from Belgium, the new one costs 80 euros per square meters. The reclaimed one, Belgium, is 60 euros per square meters, is less. But the new one from India is 40 euros per square meters. And so, like, it's cheaper than the local one, but it's more expensive than one that is produced in India, and maybe there is some children on the quarry that extract this cobblestone. So the question is how to compare new with the second-hand materials, and also like to accept, you need, again, this question of what type of economy do you want. If you want circular economy, it's that type of way of working. You need flexibility. You don't have a large quantity of materials. We always say that it's an open-air carrier, the city, for salvaging the city, but it's not a carrier, because a carrier is like you have a land, you make a hole, and with the machine you extract the stream of elements and you produce like industrial production. But like reclaiming building elements is more closer than the mushroom collect on the forest, you know. You need to access, if you want like 1,000 square meters of ceramic tile, you need to access maybe to 5 buildings, so 5 different owners. You don't have the visibility of these 5 buildings, what is inside. They're gonna be all different size, different color, different way of joining. And then you need to reunificate this batch and to mix them to create this amount of tiles that you want. So circular economy is there. We know that it's that side, it works like that. If you want this type of economy, you need to work with that. But it's dangerous to try to massificate or to make this circular economy same as a linear and industrial economy, because it's nonsense. So maybe like when you want to build the 80,000 square meters office building, maybe we don't need to build this anymore, or you need to deal with what is already there and put your building in another one. But we won't be able to give you 80,000 square meters of fake ceiling or stuff, because it's too large and it's made with this industrial economy. So it's, again, the question is about like which type of economy, and like take it as it is if you want to work with it.
I think think we need to close slowly. This super interesting discussion, which could go on forever. You have been talking for 6 hours before with our students, so maybe it's time for you to rest a little bit. Just maybe closing remarks, either to what you saw today, what you spoke about today, or what to challenge each other, or just to comment. And I think then we can conclude with the evening, either with a question or with the position.
That's complicated. No, yeah, I don't know. I think we're so close to each other that I know so well your work that I don't know what I would been able to ask unless like super detailed question that's not for you. So no, yeah, I will just talk maybe more generally. So I was really impressed also today of seeing like this changing, because when we started with BC Material, or with BC in general, and there was really like this absolutely no response from the sector. No one was interested with, and there were like in Belgium, for example, many companies already like trying to make a very interesting product like bricks, like earth bricks, what we are doing now. There were companies doing that, but at that moment, I think I'm talking only 15 years ago. The market was not ready for that, so they built it like companies and industry in order to create a certain offer, but there was no demand, not at all. And I have the feeling, and that's a very positive feeling that I have, is that no, the time has changed. There is really like this demand and a real change also through young architects that want to create impact and want to have change. When I was studying architecture, that was about your concept and how your project would look like. Now we're talking about how we're going to build it and how we're going to make impact about it. That's really something new. So I have the feeling now that we are at the right moment to be able to make change and for me to sell some bricks. So that's good.
Thank you.
Okay, so I won't ask you a question again. But I will share like a few stuff that I share to the student. But I was really impressed by the work of the student this morning, and like a lot of studios are working with this question of reusing building element, what's already there, and everybody is struggling. Again, it's because you crossed the end in the other sense, so it's normal. So it's the first step, but it's gonna be more easy. And the thing is, if you want to, architecture is really simple. It's like making holes somewhere and like putting a pile of material, organize this pile somewhere. And if you want to stop doing hole, you can like explore this question of reclaiming building materials. And the good thing with it is it's a dynamic still architecture because you circulate the materials. So it's kind of an enthusiastic approach also of rediscovering architecture. And I think what is really missing and what I encourage you to do is like to explore the tools. You need to change your tools of designing when you change your practice. So to think about other field of research in archaeology, in preservation and heritage, in I don't know which other science, but we need to develop these tools to show new information that we want to manipulate, and it's going to be much more easier. So this is an invitation of being close to the context. It's always like tailor-made or always like contextual question, and develop your tools, think about this to make it easier.
Thank you so much, Victor. Thank you, Nicolas. Amazing. Thank you, everyone. I just want that we would like to go home today and maybe having in mind that we have to redesign our practice with different tools and with different knowledge, incorporate common sense, but that our responsibility in the education, it's also redesign the pedagogy in order to come closer to the goals and impacts that you have been providing us today. So thank you for your energy and hope to see you again soon in this institution. Thank you.